Alright, now we are going to do a Radxa VRX build. So I've already gone ahead, 3D printed this out of TPU. I've got the button board already in there. So basically these are just antennas to solder on to the RTL adapter, and this one is to plug into the RTL adapter. So this is an RTL 8812 EU, about $16. This is just some breadboard, and then this is the old run camera adjustment button from the analog cameras. This is just an LED that I had, which I wire to the Radxa's status LED, so that you can have the status LED show through. And then this is just a button off a Cadex camera controller as well. Radxa 3E, because it's cheaper at the moment and still the same features. There's just a few different things on it that you gotta be aware of when you're doing the case as well. So this one came with pins. I don't like having pins. It's also got this LAN connection instead of wireless, so I might have to desolder that, we'll see. And where the SD card slot is, that's where your MIPI cable is. So the SD is in a slightly lower position than the 3W, I believe. But other than that, performance wise, it should be exactly the same, so we're sticking with that. These are 5 amp 5 volt BECs. Now these are, I'm pretty sure, 48 volt tolerant. So I've got 2 of them, so I want to run 10 amps. A USB hub. So this one basically gives you what, 1, 2, 3, 4. You can piggyback off that one. And the capacitor, I usually put the cap on the USB hub. So I'll just take the power and ground connection and just put one there, because that way I can fold this all into one unit and put it aside. Now I've already hacked the USB-C cable before because I needed the other end of the USB, and this is a data. So you need a data male USB connection. I'll be stripping this down because it just has a solder board like this underneath it. So you need one of those to plug into the Radxa. So that'll be plugging into this port, and then you'll be piggybacking the hub off that. Now I'm using 2 female connections because the case itself is designed, it has 2 USB slots. I'm not gonna break out the OTG because I'm never gonna be using that for power. Then you get your RTL 8812 EU adapter. These are about $16, pretty cheap. And these can pump out 550 milliwatt, probably more if you, but at 3 amps I've measured, well 2.8 amps, I've measured 550 milliwatt out of these, so not bad. You get 2 of those. Bam, and there's your high power setup. Basically, that's it in a nutshell. And that's your OpenIPC VRX. So, I'll start soldering. I'm currently printing the base of the case now, if you can't hear it, since I already have this here. We have a little DC jack. I'll be using this wire. So you're gonna need a decent thickness wire to feed power from your 5 volt BEX. I'll feed power from the 5 volt BEX into the USB. Okay, not ideal, but I'm just gonna do that, and then I'm gonna slip some heat shrink over. And it should still come down to a decent height, because all I'm worried about is keeping the height low so that the cards on top won't foul on anything. And having the pins there means it's gonna, you know, poke into something. So whatever I don't use, I think I'll just cut off. I don't like that, but we'll go with it. Now with my first Radxa VRX, I'll do a ground there, and then I'll do a ground there. And then for the status LED, we are actually gonna tap off that LED. So get the thinnest wire you can for that one. Oh, delicate 3.3 volt. I need to wet my sponge, it's a bit dry. Everything's just got extra length, we'll trim it up once it's in position. So we'll give it probably not quite a service loop, but enough slack. Aha. So the 3E is slightly different height there because it doesn't slot into the holes. Yeah, and it pushes out there a little bit. So maybe we can trim this little pad off. Oh yeah, I print my cases in TPE 100%. Like, it's flimsy and flexible, which is good when you're working on it. It allows you to, you know, manipulate things a bit better. But once it's together and shut, it's quite stiff. So on the USB hub, you have the labels here. It's USB 1, USB 2, USB 3, USB 4. And then at the very top, right there, there's two tiny holes. That's your 5-volt in. So plus on the outside, minus on the inside. Now we have to make the puck. So what we're going to do with the puck, they're 5 amps each. You stack them on top, join them, and then yeah, wrap it up and stick it in here. Sideways, like that. I am just going to cut this off because I don't want it. Okay, I'll just remove that steel plate because I don't want that touching anything. I'll be trimming these as well, make sure everything's off. So, with the hub, you got to make sure that you have USB 1 and USB 2 as your your A unit, oh not A units, your RTL EU adapters. I'm gonna have power coming in here, loop the 2 wires in the input, and then I've orientated it like this so it's a shorter distance to the hub. While we're here, I'm going to strip this down so you can see what's in it. So you can see the little circuit board there. There's a little male USB to go into here, and we wire it off this one. Oh nice, this is a full data one. Damn. Seems to be a waste to use it just for standard USB data. .5-volt deck of 10 amp worth into thick boy line USB hub, thick boy ground USB hub, extra ground I'm going to put into this slot since it's connected to ground, USB male to Radxa, USB female as input, USB female as input. Now we made sure everything fits and still reaches. Bang bang, bang rang, bang rang. So that all fits nicely, and that all reaches. I'm just heat shrinking. So as you can see, just heat shrink the little circuit board, and with these wires being thin, I'm just gonna beef it up with some hot glue around there. So that's power supply and USB hub. That's pretty much most, yeah, a lot of the soldering is for this. Okay, now you get our blue adapters.
and it's numbered from the arrow 1, 2, 3, 4, 5, 6, 7, 8. Now I do believe it's 5 volt data minus data plus ground. Let's have a look. There we go. Here's the input, here's the output, here's the input. 2 by 5 amp, 5 volt outputs. Pretty sure these can take 48 volt. We'll add the cap. There we go, fitted it in there. We route the USB into the Radxa under the board, the USB input under the board. As you can see, we're not using the on-the-go USB, we're not providing power through that. And there's our USB hub, there's the capacitor, here's our power supply brick. And pretty much, that's how everything will fit in there. Beautiful. Okay, you can't have 2 there because of the height of this buck converter. That's alright. That's why I gotta cut the pins, so then it can just sit in there. 3.3 volt. Just gotta go to the button. Now the standard idea is just to have a quick action button there instead, but I like to have a status LED. Just like that. Now, check this end over here and see if it powers on. So, I've had to change the LED to a green one because that being green, it's got the resistors for green. So I can use red or yellow, but blue or white I need higher voltage for. So you have to change to a green LED. But as you can see, it's taken over that and it's flashing here. Alright, so I rearranged everything. That's just with the lid. Alright, so one blue adapter in there. And I didn't have any UFL, so I just soldered it in there. So I've found myself a little DC jack, but it's like for a scooter RGB lights. Now because the hole is pretty small and very close to the USB, ideally you just want like a 90 degree or a very short stumpy one. But these, when you strip them, they're that long. Oh no, this one's actually just a board. Nice. Oh, it's dark. But yes, there you go. It's gonna sit in here, bang a rang, like so. And I'm gonna make it protrude a little bit so that it's not gonna put any pressure on the USB. Now I'm just gonna put a little sleeve over this just to Just so when it pokes out of here, it's black, you know, it's not gonna grab your attention too much. Once I have a 30mm fan, I'll be sealing it up, closing it up. So I just put a dab of super glue on all the tabs. And it holds. It holds very well. There we go. Change of plans. This little brick, it was a good thing I didn't activate it. I had to jump these pads to activate it. I picked a spare one up and tested it out, and output 9.2 volts. So there's a seller on AliExpress that's selling these called mini 560s. Better make sure what you get is correct, because I've just read the other comments that were hidden and people are complaining that yes, he doesn't care, he just sends the wrong shit and dead boards. So watch out for that mini 560s. I've just gone for this big boy instead. It's a bit unsightly, that's the change. So it's a bit bigger and tighter, but as long as you put the actual puck down, it'll fit in there. So now it's just a matter of getting a fan. Here's an RC car, 1/10 scale with an ESC, and these fans fit perfectly. So we'll be stealing this one. So get this one. So we'll be doing a suck through. Push this protection tape a bit further in. Yeah. And then we just go around slowly. A little bit too much there. Ta-da! Okay. There we have it. A little dab of super glue there. That's all right. Okay. 3S for the drone. Fan. So get the fan going as well. Turn it down so it's not too crazy. Power on the Radxa. So status LED going good. go. Nice. Woo. Might as well show the quick action buttons. So that little guy is the start, stop, record. Process recording file. Menu, press down, down, up. OSD change, back. Now, little trick. These are my settings. I always choose a preferred interface. This is for an uplink, and then 40%. Radio data rate, this is the one that I change myself. I'll always change that. I usually put that at MCS 0, but I'm going to try lowest, which is MCS 0, but hopefully it just stays there. MCS 4, I do believe it'll be adaptive up to that, so yeah, here we go. There you go. It's a lot quieter now. Excellent. So that's how you do a Radxa ground station. Hope you enjoyed that.